Okay, here we go. So guys, we're going to be solving square roots and other radical equations. Literally, this is the lesson right here. This is all you have to do. First step. So if you need to take a picture or write it down, you got to be quick. So first step when solving a radical, you first isolate the radical completely. Meaning, get the radical alone. Nothing added, subtracted, multiplied, or divided to the radical. Second step, once you have the radical alone, undo the radical, get the radical away by using the inverse. So what undoes a square root? A square. What undoes a square? A square root, right? Then third, once you've gotten rid of the radical, if need be, use algebra to solve for x or for whatever variable we're talking. And then we just have to check our answers. Technically, our fourth step is check our answers for extraneous solutions. Here we go. Now remember, an extraneous solution just happens because we're manipulating this equation so much that we might get an equation of the new derived equation, but it's not truly a solution of the original. So we just check our answers. So isolate the radical. Won't I subtract 2? Yeah. Then divide by 5, right? Yeah. So root x equals 10 divided by 5 is 2. Now undo the radical. So how do we undo the square root? Square both sides. X equals 4. Now we check it. Watch, the checking's not too bad here. It's not like the rationals where it's hard. So 5 times the square root of 4 plus 2, does that equal 12? 5 times 2 plus 2 equals 12. 12 equals 12 is true. All is good. Let's do another one. Number 4. Isolate the radical. It's isolated, so we would undo it. So we would square both sides. 2x minus 5 equals 49. Then what will we do? Add 5, so we get divide by 2, x equals. Now we'll check it. So we have the square root of 2 times 27 minus 5. You could literally just type it into your calculator. Does that equal 7? You got 7? Okay. If you did, then 7 equals 7 is a true statement. So we're good. Let's do another one. Number 5, what would we do first? Okay, I think you guys can do it on your own. Go for it. Don't watch me, and you're cheating. $13, right? Yeah. Then check it. Okay, you're good? We're good then? You've checked it for us. Okay, cool work. Okay, number 11, what would you do first? Add 4, then you'd cube it. Not cube it, you cube both sides, right? Okay, go for it. Okay, go for it. Does anyone have questions? Pretty straightforward, right? We're in the kiddie pool right now. Let's stick in the kiddie pool for a minute. 1 through 12, go for it. Okay, so look at this next section here. Now notice something. We're now dealing with rational exponents, but no fear. We know that that's the same thing as a radical, correct? So this is how I have my secondary math 3 regular students do it. I make them every time rewrite it as a radical. So isn't this the cube root of x minus 2 to the first power equals 5? And that was no different than what we just did, right? So we cube both sides. So we have x minus 2 equals 125 because root cancels out power. And then we have x equals 127, and then we would check it. But we are going to think more densely since we're in honors. So we're going to do the same thing algebraically, but we're just going to not rewrite it as a radical. We'll just say, let's raise both sides to the third power. Now, same thing that we did, right? So look, raise a power to a power and you multiply. Look, a third times 3 is 1. So we have x minus 2 equals 125. It's the same thing we did over here. It's just thinking about it more on an advanced level. Make sense? Okay. Oh, did we not finish? No, we did. And then we would check it. Okay. Let's look at another one, number 5, 15. Okay, here's what you have to be careful of. The first thing you have to do is isolate the radical. So because there's not parentheses here, 2 is not raised to the third power and 2 is not under a fourth root. So we've got to get rid of 2 first. Okay, good. We divide both sides by 2, so we have x to the 3/4 equals 8. Now let's think advancedly here. How would we undo 3/4? Raise both sides to the 4/3. Now look how nice that is. We have a 12 over 12, which is 1. So x equals, now do not touch your calculator. I want you to think how easy, watch how easy this is. This literally means the cube root of 8 to the 4th power. What's the cube root of 8? Just positive 2, correct? Cube root of 8 is 2. So we're doing 2 to the 4th power, which is 16, correct? Do you see how I did not even need a calculator?
Yeah.
Let's check it. Watch. 2 times 16 to the 3/4 power. Does that equal 16? Now watch, you should not even have to touch a calculator, especially because you can say the 4th root of 16 is 2. 2 to the 3rd power is 8. 8 times 2 is? So 16 equals 16. Okay, you guys do this one. Ready, go. So you got to this point, the cube root of 27 is only positive 3. 3 squared is? Is anybody having problems with these? Pretty basic. Okay, now here's what we've got to be careful of. This is what's called a red flag problem. Here's why. In our other 2 examples, when we were solving, in the process of solving, we were doing in the process of solving a cube root, which only had 1 root. Look, cube root, which only had 1 root. But what if when solving, we have an even root? So let's do number 23, then I'll let you practice. Here we go. First thing we do is add 4. So we have our x minus 2 to the 2/3 power equals 9. To undo 2/3, I'm going to raise both sides to the 3/2. So now look, 6 over 6 is gone. X minus 2 equals. Now if you think about this, if you just type it into your calculator, a lot of people miss this on the test. Statistically speaking, a lot of people forget to do this. When we're solving, we are going to need to put plus and minuses. When solving, when simplifying, no. So let's look. The square root of 9 is plus and minus 3 though, correct? The square root of 9 is plus and minus 3. So we're dealing with plus and minus 3 to the 3rd power. So now we have 2 solutions. X minus 2 is equal to positive 3 to the 3rd, which is 27. And we also have x minus 2 equals negative 3 to the 3rd, which is negative 27. So do you see how easy it could be to forget to put plus and minus? Yeah, a lot of people, I'm not kidding, miss it on the test. So let's make sure we don't forget. So now solve. We'd add 2, so x equals 29. We'd add 2, so x equals negative 25. Then we would make sure to check both of those in our original problem. When you're solving and you take an even root, you need to put a plus and minus. Okay. Do you want to go through the checking, or do you think you're pretty confident with checking? Okay, cool. Then I'll just let you go for it. Hey, go for it. Finish the front. Okay, go to, I would have worked less if they would have let me. Okay, go to 29. Let's go graduate to the big kid pool. Okay, now guys, it doesn't get any harder. The algebra gets harder, meaning you just have to be more careful. You can do it though, guys. Here we go. So it says, the first step says to isolate the radical. So our radical is isolated. Now undo the radical. What will we do? Square both sides. Now there's 2 terms. Make sure you use parentheses. So root cancels out with power. We have x plus 1 equals. We know it would be breaking the most forbidden of all forbidden rules to just square that and square that. Can't do it. So over here, we would have a quadratic, and we're going to have to solve it by setting our quadratic equal to 0 and solving. So we're going to need to put it in standard form. So rewrite that out. So we have our x plus 1 equals x squared minus x. So x squared minus x, won't that be minus 2x plus 1? We solve quadratics by getting them set equal to 0 and solving by factoring your quadratic formula. So let's get it equal to 0. Subtract x, subtract 1. 0 equals x squared minus 3x. Let's solve by factoring. Why? Because this is an easy one to factor. In fact, we'll always solve by factoring if we can. So we'll pull out an x, won't we? So x minus 3, linear factors means we can set each of those equal to 0 and solve. So we get x equals 0 and x equals 3. Let's go check them. Guys, once we start manipulating these more and more, the harder they get, the more likely there is for extraneous. Watch, let's plug in 0. So plugging in 0. The square root of 0 plus 1 equals 0 minus 1. Now, keep in mind, we're not solving at this point. We're just simplifying. So we would not do plus and minus. So this is the square root of 1 equals negative 1. Square root of 1 is 1. Does 1 equal negative 1? No. So we have an extraneous solution. We got to cross that one out. Let's check 3. The square root of 3 plus 1. Does that equal 3 minus 1? The square root of 4 equals 2. So 2 equals 2 does work. So on the test, this is exactly how you'd write it. You show me you got both of them. You check this one, and it's no longer a solution because it's extraneous. Questions? Okay, let's do another one. This is so much fun. Okay, look at 31. What do you suggest I do? I what? Square both sides. Okay, you guys go for it then. Go for it. I broke the forbidden rule. Don't even think about looking up here until you've done it completely by yourself. You want to find it in the joke? That's mine. So you should have got solutions. X equals 9, X equals 2. Did we all get that far? Yeah. Okay, let's check 9. So you'd say 9 plus 7 to the 1/2 power. Does that equal 9 minus 5? So look, 16 to the 1/2 power equals 4. Square root of 16 is 4 equals 4. 9 works. Let's check 2. Okay, plugging in 2. So that's going to be 9 to the 1/2 power over here. Does that equal 2 minus 5? Square root of 9 is 3 equals negative 3. Heck no. Extraneous. Cool. This is fun. Let's do another one. They're going to keep getting harder and harder. Not too bad though yet. Hey, actually, you guys go for it. This one's not any harder. Go for it. Oh, is that one? Who got x equals 6? I did. Nice. Way to go. Let's move on. Did you check it for me? Okay, yeah, go check it. What? 40. Okay, look at 42. First rule, always get the radical isolated. There's two radicals, especially if you have two radicals, you're only going to want one radical on each side of the equation, always. Because there'll be lots of simplification involved. So I'm going to bring this over with addition, so that we have the square root of 7x minus 6 equals the square root of 5x plus 2, which with this one is very convenient, because what will we do next? Square both sides. Root cancels out power. Oh, nice. Root cancels out power on both. Now we're just dealing with a very easy linear equation. Okay. That one wasn't very hard. All right, now let's get to a good one. Yes. So 43, first things first. We have 2 times x minus 1 to the 1/2 power equals 26 plus x to the 1/2 power. What do you suggest we do? Isolate the radical. Aren't they technically isolated? So what should we do next? Good point. You're right. You're both there. Yes, we need to square both sides, but then we have a 2 here. So let's see what happens if we square both sides. So good point. Now, isn't this a times sign? So it would not be breaking the forbidden rule. Hey, group 7. It would not be breaking the forbidden rule to square that, square that. That would be what we needed to do, right? So we're all good here. 2 squared is 4. This squared is just simply x minus 1. Just make sure the parentheses did not go away. Now over here, that became a 1. So now we have 26 plus x, and what do you know? A linear equation that's not too bad to solve. Multiply 4 in. 4x minus 4 equals 26 plus x. We would check it, and looking good. Yep, square root of 36 is 6, and then right here we have the square root of 9, which is 3 times 2 is 6. Okay, I checked it. Hey, look at 44, a more advanced one. What should we do here? Tell me. Yes? Yeah, we could raise it to the 4. Okay, bring that over here, okay? We have x minus 1 to the 1/2 power equals 2x plus 1 to the 1/4 power. Very good to remember. We need to isolate our radicals. What should I do next? Any suggestions? Good point, but actually it's a good thought though. Okay, so I'm hearing some people saying, let's take care of the bigger radical. Let's raise both sides to the 4th power. That is an excellent idea. I'm always going to get rid of the big radical. So now look what happens. 4 times 1/2 is good, 2. Yeah, so this is just squared now. Is equal to, now look, that becomes a 1. So it's equal to 2x plus 1. And look at that, a quadratic, we know how to solve quadratics. Yeah. We would multiply this out, x squared minus 2x plus 1 equals 2x plus 1. Solving for x, subtract 2x. So x equals 0, x equals 4. Check them. You're saying this one's extraneous? Yeah. Okay. Okay. Why? Good point. If we plug in 0 right here, 0 minus 1 is -1. -1 to the 1/2 power is the square root of -1, which is I. Nope, can't happen here. Okay, good point. As long as it was an I. Good point. So we could have an I as long as we were subtracting by I. So if we plug it in here, it's not I. Good point. Good point. So do you see how Connor is saying it? Okay, this is my last example. Then I just want you to practice them on your own. You need to see this one, I promise. This is the hardest one. Okay, first, what should we do? Isolate the radical. So we can add this over this way. So we have root 2x equals 1 plus the square root of x plus 1. Next step, square both sides. Now, there's two terms. So we have 2x, because root cancels out with power, equals. It would be breaking the most forbidden rule to just square that, square that. Yes, we have to do this and multiply it out. Okay, watch me very carefully. 1 times 1. 1 times the root of x plus 1. Then that is the root of x plus 1. Then what's this times this? Okay, what? Yeah, yes, good point. Wouldn't that have been easier? No, that's a good point. He's making a good point. We could have been easier. Wouldn't it have been easier technically to bring this one over? Less simplification, but where we're this far, good point. Let's just keep going. Okay, well that times that. So I want to be, yep, x plus 1, everybody. Does everybody understand why it's just x plus 1? Group 7? Okay. So we had 2x equals this. Let's combine like terms. 2x equals 1 plus 1 is 2 plus x plus how many root x plus 1s? 2 root x plus 1s. Because when we combine like terms, the apple doesn't change, right? Okay, like, remember how I would say that? Okay, whatever. I said it regular. The radical doesn't change. The apple doesn't change. Sorry. Okay, are we good from here? Next step, isolate the radical. We have a new radical, but it's okay. Let's isolate it. So I'm going to bring these over away from the radical. Subtract 2, subtract x. Subtract 2, subtract x. Now look, combine like terms. 2x minus x is 1x minus 2 then equals 2 square roots of x plus 1. Now guess what people want to do next? They want to divide by 2, but then if I did that, now I have fractions. Watch. If I divide by 2, I have x minus 2 divided by 2 equals the square root of x plus 1. And then when I square both sides, I don't want to have to deal with fractions. So instead, I'm going to leave it. I'm going to just square both sides here. So now look, this side we're going to multiply it out, aren't we? X squared minus 4x plus 4 equals, now look, we've got to square that and that. So when we have a 4 times x plus 1, and we have a quadratic we can solve. X squared minus 4x plus 4 equals 4x plus 4. Subtract 4x, subtract 4. So when we have x squared minus 8x, so then take out an x. X equals 0, x equals 8. We've got to check them. We have to check them. So look, the square root of 2 times 0 minus the square root of 0 plus 1, does that equal 1? The square root of 0 minus the square root of 1, does that equal 1? 0 minus 1 equals 1. Negative 1 does not equal 1, so we've got to throw out x equals 0. No. Then 8 worked. Okay. All right, finish up. I need you to practice some of those on your own. Now look how cool. So this is a long problem, yeah? Yeah. But now you can feel cool because you can go say to your mom and dad, look what I'm doing. Okay. It's cool, right? You think that's long, you wait till you get to calculus. Okay. What I want you to do now is practice them on your own. Watching me do it, I make it look easy. Doing it on your own is a whole nother ball game. Ready, go.